Just a correction on the last slide. I kept saying tantalum is element number 79. It is rather atomic number 73, so that's my correction. Now I want to do two other problem solving. In this problem, they give us the density of the pure metal lithium. They also give us the information about the sides of the cube. And they say, what is the possible packing structure? Your possibilities are either simple cubic, body-centered, or face-centered. But before we go on to some sort of calculating detective work, let's decide how many atoms we have for each of these possible packing structure. For simple cubic, don't forget you have only 8 corners, 2 in the back, 2 here, then 6 and 8. Each are sharing 1/8 of an atom. So that's only 1 atom per cell. In case of body-centered, you still have your 8 in addition to 1 entire atom. So you have 2 atoms per cell. And finally, face-centered has the most. You have the 8 corners, so that's 8 times 1/8. Plus you have 6 faces. Each face is sharing half of an atom, so 6 times half. So you have 1 plus 3. You have 4 atoms per unit cell. And we are going to see how we are going to apply it into our calculations. So first I'm going to go after the distance that is given to me, calculated by Bragg equation from X-ray diffraction, and I'm going to make it into my volume. So volume of a cube is simply side times side times side is d cubed, and it's equal to 0.35 nanometers cubed. But I'm going to convert nanometers to centimeters, so that's my first job. Now, all questions are usually picometers. This question is nanometer, no big deal. You should remember 1 nanometer is, nano is 10 minus 9 meters. But we like it into centimeters, so 1 nanometer is actually 10 to minus 7 centimeter. So now the volume of all of the cubes are the same, is equal to 0.351 times 10 to minus 7 centimeter. Cube the entire thing, and when you do that, you're going to get 4.32 times 10 to minus 23 centimeter cube. So that will be our denominator for density. Now let's see what is the mass. The mass is going to change according to how many atoms you have. In the first one, you only have 1 atom in it. So in case of a simple cubic, I'm going to calculate the mass. Mass is 1 atom times Avogadro. We are going to convert it to moles. 6.02 times 10 to power 23 atoms equals 1 mole. It is lithium, so we go to periodic table. Lithium has molar mass of 6.94 grams. Like units cancel each other out, so you have 1.15 times 10 to negative 23 grams. So let's just calculate density as if it was simple cubic. So density is mass over volume is 1.15 times 10 to minus 23 divided by the volume, which was 4.32 times 10 to minus 23 centimeter cube. If you do this calculation, you get density to be equal 0.266 gram per centimeter cube. It is not 0.535, so simple cubic cannot be the possible structure. So let's try the next one. Let's go after body-centered. So body-centered cube. Now I'm going to just calculate density directly. Is mass over volume. Now the difference is I have 2 atoms versus 1 atom. So my mass is twice as much. It's 2 times 1.15 times 10 to negative 23 grams. the volume did not change, 4.32 times 10 to minus 23 cm cube. If you do this, you will get to be 1.06 gram per centimeter cube. It is not what they gave us in the question, so body-centered cannot be the answer. So the only choice left is face-centered, but let's just double check, so let's just calculate it and see if that's the case. So for face-centered cube, density is mass over volume. The difference is I have 4 atoms, so the mass is 4 times as much. 4 times 1.15, 10 minus 23 grams, divided by the volume that did not change. All cells have the same volume. And when you do this, you get exactly the same answer as the question, grams per mole. So it is face-centered, and that's your packing structure. Now the last question for this segment, they are asking us to determine density of gold, and they also give us this information. It is face-centered cube, and this time they give us the radius of each atom. That's all they do. So my job is, the first thing is I have to find these distances d, which then I can find my volume from. So let's just do that. Now if you look here, this is becoming a triangle, and if you look at your hypotenuse, this is I have 4 r's. This is a r, this is a r, another radius, and 4th radius. So the hypotenuse is equal to 4r. So it is a right triangle. I have d as side, d as side, and this hypotenuse is 4r. According to Pythagorean theorem, 4r, if you square the entire thing, is equal to side square plus side square. This is a right angle triangle. Therefore, 4r squared is equal to 2d squared. Now let's just take square root of both sides, and you have 4r equals square root of 2 times d. So now d can be expressed in terms of radius is equal to 4 times radius divided by square root of 2. So if that's the case, let's just plug it in. So each side is equal to 4 times 144 picometers converted to centimeter, divided by square root of 2, which is 1.44. I write it as square root of 2, and then volume is d cubed. So once you calculate this, just plug it in, and for volume I have calculated 6.76 times 10 to minus 23 centimeter cubed. Now the last thing to remember, this is face-centered cube, so not only you have 4 atoms, remember 8 corners plus 6 faces, so you have 4 atoms. So in terms of calculation of mass, we need to respect that. So 4 atoms of gold. First I'm going to convert it into moles. Is equal to 1 mole. Then I'm going to go to the periodic table, look up the molar mass. Every 1 mole of silver is 196. Gold is 196.97 grams. So when we do this, mass of gold is 1.31 times 10 to minus 21 grams. So finally, density is mass over volume. And it's equal to 1.31 times 10 to minus 21 grams divided by the volume, which was 6.76 times 10 to minus 23. If calculation is performed correctly, it's 19.4 gram per cm cube. 9. Let me just... So it's 19 grams per centimeter cube.